Okay, let's try to graph r equals 1 minus 2 sine theta. So we'll look at it in as r theta being in the Cartesian coordinate system, and then how that transfers over into polar coordinates. Okay, let's just graph the sine function. We know some transformations are happening here, so just the sine function will have max and min at 3 pi over 2 and pi over 2. So I'm going to make that dotted because, again, that's not my final graph. So there is the sine function. And then I have negative 2. Sine, the amplitude was 2, that's why I went to 2 and negative 2. But if I'm looking at, there should be a 2 there because I went to 2 and negative 2. The minute I look at negative 2 sine theta, again, all I've done is reflected it about the x-axis. So this graph, of course, we can look at our TI, but just a quick review of trig. So it's going to get reflected about the x-axis. That negative is going to make the y's act the opposite. And then if I think of that as just 1 being added to that guy, which is the same as 1 minus 2 sine theta, I'm taking this blue one and shifting everything up 1 unit. So 0, 0 will go to 1, 0. Negative 2, or pi over 2, negative 2 will go to pi over 2, negative 1. This guy again will go up 1. This one that was at 2 will go to 3. And this guy that was at 0 will go up to 1. So the final curve I'm looking at is really this in the Cartesian coordinate system. So if I'm going to do an r theta analysis to see how the pieces of the polar curve develops, it might be good to see what these points are, meaning what angles caused my r to be 0 between 0 and 2 pi. It's not clear here, so I'm going to go let r be 0 and figure out what those two angles are that made r 0. Kind of like the idea of x-intercepts, that'll translate to how it goes into the pole, into the origin of the polar curve. So basically r becomes 0 when sine theta is equal to half, and it looks like the two angles we're going to get are going to be pi over 6 and 5 pi over 6. So sine's positive in quadrants 1 and 2, and I have opposite over hypotenuse, so it must be the 30, 60, 90 triangle. So the two thetas are pi over 6, 30 degrees, or 5 pi over 6, 150 degrees. So these that were kind of important when I go to the polar curve, I'm going to label pi over 6 there and 5 pi over 6 there for those two angles. Now we're going to go see how this creates the polar curve. Again, we are going to look at our TI and see how the pieces develop. So we have the TI calculator to look at also, but it's good to see visually how this transforms into the polar curve. When we look at areas between curves and such, it's good to know between what angles what really happens as opposed to just the final curve. So I have the angles that I need that seem to be important labeled, pi over 6, 5 pi over 6, and all the other ones. And also I'm having my r's go as 1, 2, 3 with 0.5, 1.5, and 2.5 because otherwise the graph would look too jumbled up together. So remember, all the way to outer circle is 3 units out for the r. So let's see what happens between 0 and pi over 6. As I go from 0 to pi over 6, it looks like my r value was at 1, but it decreased down to 0. So from 1, it went to 0. So here I am at 0, and my r value is 1. But then as I go into the pole, I go at a pi over 6 angle and go back to 0. So I'm going to say it looks something like that. Maybe going into pi over 6, the r value is 0. So that was the first piece. Let's label all the pieces that I got from 0 to pi over 6, which was this little piece. The next one is from pi over 6 to pi over 2, and it seems like my r values are negative. So let's keep that in mind. So that when I'm between pi over 6 and 5 pi over 6, I'm actually going backwards on the extension of the ray to get my r values in sort of the opposite side, not on the side that I'm at. So between 0 and pi over 2, I go from 0 to negative 1, it looks like. So as I'm sweeping through here, going from pi over 6 to pi over 2, R values are going from 0 to -1. So no action is happening here. All the action is happening on the region across from it because all the R values are negative. So nothing between 0 and pi/6 in this region, no R values. R values are really down here. And it's going from the 0 that I was to -1. So at pi/2 itself, remember right here, it's going to be at -1. And it just sweeps through. I'm doing a sketch, so it's not really completely accurate. It goes from 0 to -1. I'm sweeping here, but action is happening really over here because R's are negative. Still with the negative R's, from pi/2 to 5 pi/6, I'm going from -1 back to 0. So even though it's increasing all the way through, I'm going to go back to the pole, the origin here, to see what happens from pi/2 to 5 pi/6. So as I'm sweeping from pi/2 to 5 pi/6, again my R values are negative, so nothing's happening here. Stuff's really happening across from it over here as I'm sweeping, and R is going from -1 to 0. So right at pi/2, remember it was -1, but now it's increasing and going back to 0. So something like that happens. So this is, let's say, region 3, and that's region 3. And also it looks like we have pi/2 vertical line symmetry here, so we could even guess that this is the next piece, but let's go see how it develops. Now as I go from 5 pi/6 to pi, it's increasing back from 0 to 1. So all the R's are back to being positive. So as I'm sweeping through from 5 pi/6 to pi, all the R's are positive, so they remain in that region. And at 5 pi/6 itself, I was at 0, but I swept through to pi, and it kept getting bigger and bigger and going to 1. So this is piece 4 for us, contributing that little piece there. And as I go from pi to 3 pi/2, things were at 1, or R value was at 1, and now it's increasing to 3. So R goes from 1 to 3. So here I am at pi, and at pi the R value was 1, and remember, because I'm calling that whole outer second circle being R value of 1, so at pi I was at 1, but as I swept through from pi to 3 pi/2 now, the R values are positive, so action is really happening on the side that I'm at, and it's increasing, going from the 1 that I was at all the way to 3. So for my R's, I have 1, 2, 3. So it goes all the way to an R value of 3 when I'm at 3 pi/2. So I don't know, something like that. I'm sketching again. So R values just get bigger and bigger and bigger as I'm going through my angles until I get to 3 pi/2, a maximum R value of 3. So there's piece 5, and again I'm just doing a general sketch. We'll go look at the TI and see exactly what this thing looks like. And finally, of course, as we go from 3 pi/2 to 2 pi, the R values go back from 3 decreasing to 1. So from 3 back to 1. And here I am at pi/3 pi/2, and I'm going to sweep going back to 2 pi. As I'm sweeping back to 2 pi, the R values from 3 go back to a 1. So again, it's a sketch, it's a little messy, but that's the general shape of what's happening. This is piece 6, and that's piece 6. So it started here, and then it went here. Go make that little loop. The shape is part of shapes that are called lemmaison, but it looks like, we looked at one in class that was a cardioid. So it goes like that, and then 4, 5, and finally back to 6. If I want to make it a little bit more accurate, these pieces kind of should be wider, but you get the idea. So that's how the pieces develop. Now let's go look at the TI, and also just look at the shape and make sure we know how to use the TI accurately also. So I had 1 minus 2 sine theta. Let's graph this and see if we have a decent window. And you'll see how it develops. The window, let's make it a little bit bigger. Make it go all the way to -3. or -4, so we see enough of it. And it's kind of difficult to tell what really happens there unless I really zoom in. And my window, of course, is between 0 and 2 pi, and it gave the whole shape and how it was traversed as the theta went from 0 to 2 pi, which is very similar to what we got here by hand. Another thing I want to show you is that you could go to window and say, alright, let's see what happens from 0 to, let's say, pi over 2. We'll put pi over 2, and we'll push graph. And notice the only pieces that developed from 0 to pi over 2 were piece 1 and piece 2, which we had here. So you could use your TI as a tool to also see how the pieces generate. I go back to window and I say what happens only from 0 to pi. I'm going to get just those top pieces. If you want to know, of course, what happens from, let's say, pi to, I don't know, 3 pi over 2, you could see which pieces of the curve actually generate there, which is piece 5 for us, which actually happened from pi to 3 pi over 2. So it's a good tool to look at it and see the final graph also, but knowing how the shape each piece develops is important when you look at areas later. And the other thing that was kind of different and important here was finding out at which angles the curve goes into the pole, meaning when the R values become 0.